Well, I'm glad you made it back with us. We're going to do the second part of the 55s homework. We're on question number 19. And this time they give us a hydrogen ion concentration that's like this. So what I would do is I would write that in scientific notation. 1.00, that's correct number sig figs, times 10. And I have to go 1, 2, 3 times to get behind the first non-zero. So it's going to be to the negative 3. So what would be the pH? Well, the exponent is the negative 3, so therefore our pH would be 3. We could also do this formula right here, which we're going to start doing in a little bit. So here we're going to go. We're going to start using the mathematical calculation, which is right here on your cover and on your worksheet. It says logarithms can be done on a calculator too. The formula is pH equals the negative log of the hydrogen ion concentration. And again, that's stated right there for you. Find the pH of a strong acid that has this molarity, or you can write it in scientific notation on your calculator. So on your Texas Instrument calculators, which most of you have, this is the format that you're going to have to follow. If you have a Casio calculator or a different brand calculator, you're going to have to play around with it or come in and we're going to have to help you with it to try to figure out the best way of punching these numbers into your calculator. But again, the formula is this one right here. pH equals the negative log of the hydrogen ion concentration. So I'm going to hit the negative sign, not the subtraction sign, the negative sign. I'm going to hit the log button, which is right up next to the second button. If I'm going to put this in scientific notation, I would push 1. I'm going to get the EE button. You might have to hit a second button on your calculator. And then I'm going to go negative, and then I'm going to go 3 and hit enter. I could also hit the negative button, the log button, and I could put this number in as well. And I would get the same answer. When you get the answer, it should be 3 on your calculator for a pH. Pause the film and play around with your calculator. Make sure that you know how to enter it. Make sure you get an answer of 3. Now we're going to start playing around with some of the other ones. So this one says, what would be the pH and pOH of 0.0330 molar strong acid? All right, so we know the pH. We can calculate the pH based on this number right here. Because again, pH is equal to the negative log of our hydrogen ion concentration. So we could go 0.0330, or we could use the number of 3.30 times 10 to the negative 1 to negative second, and know our pH should be around 2 somewhere. So in this case, I'm going to hit the negative button on my calculator. I'm going to hit the log button on my calculator. I can put in the mathematics as this or this, it doesn't matter. I'm going to hit enter on my calculator, and if I do that, I'm going to get an answer of 1.48 with the correct sig figs. I know it's going to give you a lot more digits than that, but with the correct sig figs, that's the answer. If you don't get that, you got to play around with your calculator until you do get this to come up. So again, we're using this mathematical calculation right there on your sheet. Now, with the pH equaling 1.48, we could do some other math. So remember, before we taught pH plus pOH equals 14.0. Well, if our pH is 1.48 plus pOH equals 14.0, well, to do that math, we take 14.0 minus this 1.48, and we end up getting our pOH to equal 12.5. That would be our pOH, measure of our hydroxide ion concentration. Pause the video there, take a look at it, play with your calculator, make sure you understand everything before you move on. 22, suppose your pH is 4.58. Calculate your hydrogen ion concentration and your hydroxide ion concentration. Again, this little note right here that's highlighted, you might have to hit your second button to get things into scientific notation. So in this problem, we want to find our hydrogen ion concentration. And to do that, we're going to use either of these formulas depending on what button you have. You might have the 10N button, you might have the 10X button. But you should identify that on your calculator at this time. So a formula is the hydrogen ion concentration is equal to the 10, and on the Texas Instrument calculators these days, it's the 10X button, negative pH. And this 10X button for my calculator is a second log button. So you hit the second button and the log button, and that gets me the 10X. So the hydrogen ion concentration is the 10X button, and then I put negative, my pH is 4.58. I hit enter on my calculator, and I'm going to get a hydrogen ion concentration of 2.63 times 10 to the negative fifth. That's my hydrogen ion concentration. My pH is 4.58, so I would expect my exponent to be around that, and 5 is around that. So it's a nice little double check. But this problem also wants to know the pOH. Well, now we go back to our chart again over here. And in this one, pH and pOH equal 14. So my pH is 4.58, and my hydrogen ion concentration is this. So there's a couple ways that I can actually find my hydroxide ion concentration, which is this part on the sheet. I can go and use my pH and my pOH to get to 14.0 to get my pOH, and then I can go down here and get my hydroxide ion concentration, but that's kind of a long way to go. I know now my hydrogen ion concentration, and I can go in one step over to my hydroxide ion concentration. So the formula is right here on the bottom. Hydrogen ion concentration times hydroxide ion concentration equal 1 times 10 to the negative 14th. So 2.63 times 10 to the negative fifth, that's my hydrogen ion concentration, times my hydroxide ion concentration has to equal 1.00 times 10 to the negative 14th. You do the algebra on that, and you're going to get your hydroxide ion concentration to equal 3.80 times 10 to the negative 10. Pause it. Make sure you do that math on your calculator before you move on any further. So now we have 3 problems here at the end to solve our problems. We're going to route all these to 3 sig figs because depending on the routes that you follow to get answers, sig figs can change a lot. So if we always go to 3 sig figs when we're doing these problems, life will be a little easier and it'll be able to allow us to compare answers to each other. So in this problem, number 23, we're given the molarity of the nitric acid, and we need, first of all, to calculate the pH. Well, according to this over here, pH is equal to the negative log of the hydrogen ion concentration. This is a strong acid, which means it's going to break apart completely into hydrogen ions and nitrate ions, which means our hydrogen ion concentration in this problem is going to be equal to 0.400. Okay, that's our hydrogen ion concentration. So pH is equal to the negative log of that. So I take negative log of 0.400, and if I do that, I'm going to end up getting a pH of 1.40. So I put that up here into my chart. 1.40. Now I need my pOH. Well, I know my pH. I need to calculate my pOH, so I use this math right here. Try that on your own. Pause it. Give it a shot. The answer for the POH is 12.6. When it says acid, base, or neutral, I would always refer that back to the pH. The pH is less than 7, therefore it is an acid. What's my hydrogen ion concentration? Well, this is a strong acid, so my hydrogen ion concentration is going to be equal to that molarity. My hydroxide ion concentration, well, that's what I got to find out right here. I know this value, so I use this formula right here to get me to it. Pause the video, go ahead and do the math, and see what you come up with. And if you do that, you're going to end up with 2.50 times 10 to the negative 13th. I did a little bit of a boo-boo, and I apologize for that, folks, but here I'll show you. It said up in the instructions, use scientific notation for the hydrogen ion and the hydroxide ion. So I got to change my answer here to be 4.00 times 10 to the negative second. The reason we do that is so we can look at these exponents and find out if the pHs are close. So that's that problem. Why don't you try the next two problems, and then I'll put the answers up for you to check against. So in number 24, the answers are 13.5. This one right here, I'm going to put right down here because I need a little bit more room. Depending on the route that you followed on this map over here, you would get that for an answer, or 0.56. Yeah, it just depends on how you follow the sig fig rules and go on that map. The pH is 13.5. That is above 7. So that means we have a base on our hands. The hydrogen ion concentration I'm going to have to calculate using this formula down here. This is a strong base, so that is the concentration of my hydroxide ion. So again, strong bases break apart completely. So this molarity that we have here is my hydroxide ion concentration. I do need to write that in scientific notation per the rules. So 3.50 times 10 to the negative first. And then I use this formula right down here to calculate the hydrogen ion concentration. And for this problem, it's going to be 2.86 or 3.16 times 10 to the negative 14th, and that's just dependent on, again, which way did you go on this map to solve your problems. Make sure you pause the video and try number 25 on your own. I will give you the answers. So this is 4.00. This is 10.0. Again, the pH is 4. That is less than 7. Anything less than 7 is considered an acid. Our hydrogen ion concentration is 1.00 times 10 to the negative 4. Remember, we said if there's a 1 out in front, that exponent is your pH. And voila, that still holds true. And then my POH is going to be 1.00 times 10 to the negative 14th. And if we look at that, our exponents will match up and everything is good in the world. So, there you go. Oh, I screwed up. Sorry about that, folks. I wrote down the wrong exponent. Let's look at that again. That is 1.00 times 10 to the negative 10th, and that matches our POH, so I apologize for that. Our exponents right here, this 4 and this 10, add up to 14. And in most cases, we'll get a number that's very close to 14 if we add those exponents together. You'll get sometimes something in the 13s, something in the 15s, but often you're very close to 14. It's a nice way to check your answers. So if everything holds true, the next sheet would be your homework, which is a whole bunch of these problems. Please see us for help if you need it. Talk to you later.